a blessed day, learners. Be ready and prepare yourselves as we embark on a journey of learning and enjoyment in this video. This time, we will be studying the 8 items of physical science through the Let Reviewer Set 4B. Stay safe, and may God bless you always. Welcome to the Teacher Lumaban YouTube channel.
Commit your way to the Lord, trust also in him, and he shall bring it to pass. Psalm 37 verse 5.
Which is the induced voltage across a stationary conductor in a stationary magnetic field? Letter A, decreased. Letter B, increased. Letter C, zero. Letter D, reversed in polarity. In the next 5 seconds, select the best response from the available options. 5, 4, 3, 2, 1. The correct answer is C0. Ang tamang sagot ay C0. Explanation: when a stationary conductor is placed in a stationary magnetic field, there is no induced voltage across the conductor. According to Faraday's law of electromagnetic induction, the induction of voltage occurs when there is a relative motion between the conductor and the magnetic field. Paliwanag: kapag ang isang nakatigil na konduktor ay inilagay sa isang nakatigil na magnetic field, walang sapilitan na boltahe sa buong konduktor. Ayon sa batas ng electromagnetic induction ng Faraday, ang induction ng boltahe ay nangyayari kapag may kamag-anak na paggalaw sa pagitan ng konduktor at ng magnetic field. If either the conductor or the magnetic field is in motion relative to each other, then an induced voltage will be generated. However, in the scenario where both the conductor and the magnetic field are stationary, there is no relative motion between them, resulting in no induced voltage. Kung ang alinman sa konduktor o ang magnetic field ay gumagalaw na may kaugnayan sa isa't isa, pagkatapos ay isang sapilitan na boltahe ay bubuo. Gayunpaman, sa senaryo kung saan ang konduktor at ang magnetic field ay nakatigil, walang kamag-anak na paggalaw sa pagitan ng mga ito, na nagreresulta sa walang sapilitan na boltahe. Therefore, the induced voltage across a stationary conductor in a stationary magnetic field is zero, making option C the correct answer. Sa makatuwid, ang sapilitan na boltahe sa isang nakatigil na konduktor sa isang nakatigil na magnetic field ay zero, na ginagawang tamang sagot ang option C. What is the magnetomotive force, MMF, of a wire with 8 turns carrying 3A of current? Letter A, 2.67. Letter B, 24. Letter C, 240. Letter D, 2,400. In the next 5 seconds, select the best response from the available options. 5, 4, 3, 2, 1. To calculate the magnetomotive force, MMF, of a wire, we need to multiply the number of turns, N, by the current, I. Upang kalkulahin ang magnetomotive force, MMF, ng isang wire, kailangan nating i-multiply ang bilang ng mga pagliko, N, sa kasalukuyang, I. Given. Ibinigay. Number of turns, N, katumbas 8. Bilang ng mga pagliko, N, katumbas 8. Current, I, katumbas 3A. Kasalukuyang, I, katumbas 3A. MMF katumbas N multiply I. MMF katumbas N magparami I. MMF katumbas 8 multiply 3. MMF katumbas 8 magparami 3. MMF katumbas 24. MMF katumbas 24. Therefore, the MMF of the wire is 24. Sa makatuwid, ang MMF ng wire ay 24. The correct answer is B, 24. Ang tamang sagot ay B, 24. A coil of wire is placed in a charging magnet field. If the number of turns in the coil is decreased, what will happen to the voltage induced across the coil? Letter A, remain constant. Letter B, be excessive. Letter C, decrease. Letter D, increase. In the next 5 seconds, select the best response from the available options. 5, 4, 3, 2, 1. If the number of turns in the coil is decreased, the voltage induced across the coil will decrease. Kung ang bilang ng mga pagliko sa coil ay nabawasan, ang boltahe na sa pilitan sa buong coil ay bababa. Explanation: the voltage induced in a coil of wire is directly proportional to the number of turns in the coil according to Faraday's law of electromagnetic induction. When a coil is placed in a changing magnetic field, the magnetic flux passing through the coil changes, which induces an electromotive force, EMF, or voltage across the coil. Paliwanag: ang boltahe na na-induce sa isang coil ng wire ay direktang proporsyonal sa bilang ng mga pagliko sa coil ayon sa batas ng Faraday ng electromagnetic induction. Kapag ang isang coil ay inilagay sa isang nagbabagong magnetic field, ang magnetic flux na dumadaan sa coil ay nagbabago, na nag-uudyok ng electromotive force, EMF, o boltahe sa buong coil. By decreasing the number of turns in the coil, there are fewer loops through which the changing magnetic flux can pass. As a result, the total magnetic flux linking the coil decreases, leading to a decrease in the voltage induced across the coil. Sa pamamagitan ng pagpapababa ng bilang ng mga pagliko sa coil, may mas kaunting mga loop kung saan maaaring dumaan ang nagbabagong magnetic flux. Bilang isang resulta, ang kabuuang magnetic flux na nag-uugnay sa coil ay bumababa na humahantong sa isang pagbaba sa boltahe na sa pilitan sa buong coil. Therefore, option C is the correct answer. The voltage induced across the coil will decrease when the number of turns in the coil is decreased. Sa makatuwid, ang option C ay ang tamang sagot. Bababa ang boltahe na naiimpluwensyahan sa coil kapag nabawasan ang bilang ng mga pagliko sa coil. Which of the following is true about the frequency and velocity of electromagnetic waves? Letter A. Frequency and wavelength are interdependent on each other. Letter B. As frequency increases, wavelength decreases. Letter C. As frequency increases, wavelength increases. Letter D. Frequency is constant for all wavelengths. In the next 5 seconds, select the best response from the available options. 5, 4, 3, 2, 1. The correct answer is B. As frequency increases, wavelength decreases. Ang tamang sagot ay B. Habang tumataas ang frequency, bumababa ang wavelength. Explanation: frequency and wavelength are inversely related to each other for electromagnetic waves. The frequency of an electromagnetic wave refers to the number of complete cycles or oscillations of the wave that occur in a second, and it is measured in Hz, Hz. The wavelength, on the other hand, represents the distance between two consecutive points of the wave that are in phase with each other, such as two peaks or two troughs of the wave. Paliwanag: ang dalas at haba ng daluyong ay inversely na nauugnay sa isa't isa para sa mga electromagnetic wave. Ang dalas ng isang electromagnetic wave ay tumutukoy sa bilang ng mga kumpletong cycle o oscillations ng wave na nangyayari sa isang segundo, at ito ay sinusukat sa Hz, Hz. Ang wavelength, sa kabilang banda, ay kumakatawan sa distansya sa pagitan ng dalawang magkasunod na punto ng wave na nasa phase sa isa't isa, tulad ng dalawang peak o dalawang troughs ng wave. The relationship between frequency and wavelength is described by the equation, speed of light katumbas frequency pinarami ng wavelength. Since the speed of light is constant in a given medium, an increase in frequency must be accompanied by a decrease in wavelength, and vice versa. This means that as the frequency of an electromagnetic wave increases, the wavelength becomes shorter, and as the frequency decreases, the wavelength becomes longer. Ang ugnayan sa pagitan ng dalas at haba ng daluyong ay inilalarawan ng equation, bilis ng liwanag katumbas dalas pinarami ng haba ng daluyong. Dahil ang bilis ng liwanag ay pare-pareho sa isang naibigay na daluyan, ang pagtaas ng dalas ay dapat na sinamahan ng pagbawas sa haba ng daluyong, at kabaliktaran. Nangangahulugan ito na habang ang dalas ng isang electromagnetic wave ay tumataas, ang wavelength ay nagiging mas maikli, at habang ang frequency ay bumababa, ang wavelength ay nagiging mas mahaba. Option A is incorrect because frequency and wavelength are interdependent but not in a way that one determines the other. They have an inverse relationship, but they are separate properties of electromagnetic waves. Ang option A ay mali dahil ang dalas at haba ng daluyong ay magkakaugnay ngunit hindi sa paraang tinutukoy ng isa ang isa. Mayroon silang kabaligtaran na relasyon, ngunit sila ay magkahiwalay na mga katangian ng mga electromagnetic wave. Option C is incorrect because it states the opposite of the correct relationship. As frequency increases, the wavelength decreases. Mali ang option C dahil isinasaad dito ang kabaligtaran ng tamang relasyon. Habang tumataas ang dalas, bumababa ang wavelength. Option D is incorrect because frequency varies for different wavelengths of electromagnetic waves. Different types of electromagnetic waves, such as radio waves, microwaves, visible light, ultraviolet light, X-rays, and gamma rays, have different frequencies and wavelengths. Mali ang option D dahil nag-iiba ang frequency para sa iba't ibang wavelength ng electromagnetic waves. Ang iba't ibang uri ng mga electromagnetic wave, tulad ng mga radio wave, microwave, visible light, ultraviolet light, X-ray, at gamma ray, ay may iba't ibang frequency at wavelength. Which of the following correctly lists electromagnetic waves in order from longest to shortest wavelength? Letter A. Television, infrared, visible light, X-rays. Letter B. Gamma rays, ultraviolet, infrared, microwaves. Letter C. Radio waves, infrared, gamma rays, ultraviolet. Letter D. Microwaves, ultraviolet, visible light, gamma rays. In the next 5 seconds, select the best response from the available options. 5, 4, 3, 2, 1. The correct answer is C. Radio waves, infrared, gamma rays, ultraviolet. Ang tamang sagot ay C. Radio waves, infrared, gamma rays, ultraviolet. Explanation: electromagnetic waves are arranged in order of increasing frequency or decreasing wavelength. The longer the wavelength, the lower the frequency, and vice versa. Paliwanag, ang mga electromagnetic wave ay nakaayos sa pagkakasunod-sunod ng pagtaas ng frequency o pagbaba ng wavelength. Kung mas mahaba ang wavelength, mas mababa ang frequency, at vice versa. Radio waves have the longest wavelength and the lowest frequency among the options listed. Infrared waves have a shorter wavelength and a higher frequency than radio waves. Gamma rays have the shortest wavelength and the highest frequency among the options. Ultraviolet waves have a wavelength shorter than infrared but longer than gamma rays. Ang mga radio wave ay may pinakamahabang wavelength at pinakamababang frequency sa mga opsyong nakalista. Ang mga infrared wave ay may mas maikling wavelength at mas mataas ang frequency kaysa sa mga radio wave. Ang mga gamma ray ay may pinakamaikling wavelength at may pinakamataas na frequency sa mga opsyon. Ang mga ultraviolet wave ay may wavelength na mas maikli kaysa sa infrared ngunit mas mahaba kaysa sa gamma ray. Therefore, the correct order from longest to shortest wavelength is: sa makatuwid, ang tamang pagkakasunod-sunod mula sa pinakamahaba hanggang sa pinakamaikling wavelength ay radio waves, mga alon ng radyo, infrared, infrared, ultraviolet, ultraviolet, gamma rays, gamma ray. Option C correctly lists electromagnetic waves in this order, making it the correct answer. Tamang inilista ng option C ang mga electromagnetic waves sa ganitong pagkakasunod-sunod na ginagawa itong tamang sagot. An electromagnetic wave is radiated by a straight wire antenna that is oriented vertically. What should be the orientation of a straight wire receiving antenna? Letter A. Diagonally. Letter B. Vertically. Letter C. Horizontally and in a direction parallel to the wave's direction of motion. Letter D. Horizontally and in a direction perpendicular to the wave's direction of motion. In the next 5 seconds, select the best response from the available options. 5, 4, 3, 2, 1. The correct answer is B. Vertically. Ang tamang sagot ay B. Patayo. Explanation: when an electromagnetic wave is radiated by a straight wire antenna that is oriented vertically, the receiving antenna should also be oriented vertically to effectively capture the signal. This is because electromagnetic waves have an oscillating electric field and a perpendicular magnetic field. When a vertically oriented antenna is used for transmission, it generates an electromagnetic wave with a vertically polarized electric field. To receive this wave effectively, the receiving antenna should be oriented in the same vertical direction to maximize the capture of the electric field component of the wave. Paliwanag, kapag ang isang electromagnetic wave ay na-radiated ng isang straight wire antenna na naka-orient ng patayo, ang receiving antenna ay dapat ding naka-orient ng patayo upang epektibong makuha ang signal. Ito ay dahil ang mga electromagnetic wave ay may oscillating electric field at isang perpendicular magnetic field. Kapag ang isang vertically oriented antenna ay ginagamit para sa transmission, ito ay bumubuo ng electromagnetic wave na may vertically polarized electric field. Para epektibong matanggap ang wave na ito, dapat na naka-orient ang receiving antenna sa parehong patayong direksyon upang ma-maximize ang pagkuha ng bahagi ng electric field ng wave. Option A, diagonal ally, is not the correct answer because it does not specify a specific orientation that aligns with the polarization of the wave. Ang option A, sa diagonal, ay hindi ang tamang sagot dahil hindi ito tumutukoy ng isang partikular na oryentasyon na nakaayon sa polarisasyon ng alon. Option C, horizontally and in a direction parallel to the wave's direction of motion, is not the correct answer because it suggests a horizontal orientation, which would not be optimal for receiving a vertically polarized wave. Ang option C, ng paalang at nasa direksyon na parallel sa direksyon ng paggalaw ng alon, ay hindi ang tamang sagot dahil nagmumungkahi ito ng paalang na oryentasyon, na hindi magiging pinakamainam para sa pagtanggap ng vertically polarized wave. Option D, horizontally and in a direction perpendicular to the wave's direction of motion, is not the correct answer because it suggests a horizontal orientation that would not align with the polarization of the wave. Ang option D, ng paalang at nasa direksyong patayo sa direksyon ng paggalaw ng alon, ay hindi ang tamang sagot dahil nagmumungkahi ito ng paalang na oryentasyon na hindi umaayon sa polarisasyon ng alon. Therefore, the correct orientation for a straight wire receiving antenna in this scenario is vertically, option B. Sa makatuwid, ang tamang oryentasyon para sa isang straight wire na tumatanggap ng antenna sa sitwasyong ito ay patayo, option B. What should a good diode tested with an ohmmeter indicate? Letter A, high resistance when forward or reverse biased. Letter B, low resistance when forward or reverse biased. Letter C, high resistance when reverse biased and low resistance when forward biased. Letter D, high resistance when forward biased and low resistance when forward biased. In the next 5 seconds, select the best response from the available options. 5, 4, 3, 2, 1. A good diode, when tested with an ohmmeter, should indicate option D, high resistance when reverse biased and low resistance when forward biased. Ang isang mahusay na diode, kapag sinubukan gamit ang isang ohmmeter, ay dapat magpahiwatig ng option D, mataas na resistensya kapag reverse biased at mababang resistensya kapag forward biased. Explanation. Paliwanag. A diode is a semiconductor device that allows current to flow in one direction while blocking it in the opposite direction. When an ohmmeter is used to test a diode, it applies a small voltage across the diode and measures the resulting current. Ang diode ay isang semiconductor device na nagpapahintulot sa kasalukuyang dumaloy sa isang direksyon habang hinaharangan ito sa kabilang direksyon. Kapag ang isang ohmmeter ay ginagamit upang subukan ng isang diode, nalalapat ito ng isang maliit na boltahe sa kabuuan ng diode at sinusukat ang nagresultang kasalukuyan. When the diode is reverse biased, meaning the positive terminal of the ohmmeter is connected to the diode's cathode, negative terminal, and the negative terminal of the ohmmeter is connected to the diode's anode, positive terminal, a good diode should exhibit high resistance. This is because the diode is designed to block current flow in the reverse direction. Kapag ang diode ay reverse biased, ibig sabihin ang positive terminal ng ohmmeter ay konektado sa diode's cathode, negative terminal, at ang negatibong terminal ng ohmmeter ay konektado sa diode's anode, positive terminal. Ang isang magandang diode ay dapat magpakita ng mataas na resistensya. Ito ay dahil ang diode ay idinisenyo upang harangan ng kasalukuyang daloy sa reverse direksyon. When the diode is forward biased, meaning the positive terminal of the ohmmeter is connected to the diode's anode and the negative terminal of the ohmmeter is connected to the diode's cathode, a good diode should exhibit low resistance. This is because the diode allows current to flow freely in the forward direction. Kapag ang diode ay forward biased, ibig sabihin ang positive terminal ng ohmmeter ay konektado sa diode's anode at ang negatibong terminal ng ohmmeter ay konektado sa diode's cathode. Ang isang magandang diode ay dapat magpakita ng mababang resistensya. Ito ay dahil pinapayagan ng diode na malayang dumaloy ang kasalukuyang sa direksyong pasulong. So, a good diode should display high resistance when reverse biased and low resistance when forward biased, indicating that it is functioning as intended. Kaya, ang isang mahusay na diode ay dapat magpakita ng mataas na resistensya kapag reverse biased at mababang resistensya kapag forward biased, na nagpapahiwatig na ito ay gumagana ayon sa nilalayon. Vacuum tubes in a radio transmitter are used to blank. Letter A. Record programs. Letter B. Provide DC supply. Letter C. Generate high-power radio waves. Letter D. Provide lighting inside the studio. In the next 5 seconds, select the best response from the available options. 5, 4, 3, 2, 1. The correct answer is C. Generate high-power radio waves. Ang tamang sagot ay C. Makabuo ng mga high-power radio waves. Explanation: vacuum tubes, also known as electron tubes or valves, were commonly used in older radio transmitters for generating and amplifying high-power radio waves. These vacuum tubes, such as triodes, tetrodes, and pentodes, allowed for the controlled flow of electrons and the conversion of electrical signals into radio frequency waves. Paliwanag, ang mga vacuum tube, na kilala rin bilang mga electron tube o valve, ay karaniwang ginagamit sa mga mas lumang radio transmitter para sa pagbuo at pagpapalakas ng mga high-power na radio wave. Ang mga vacuum tube na ito, tulad ng mga triode, tetrodes, at pentodes, ay nagbibigay daan para sa kontroladong daloy ng mga electron at pag-convert ng mga decorrienteng signal sa mga radio frequency wave. Option A, recording programs, is not the function of vacuum tubes in a radio transmitter. Recording programs typically involves magnetic tape, digital storage, or other recording media. Ang option A, ang pagre-record ng mga programa, ay hindi ang function ng mga vacuum tube sa isang radio transmitter. Ang mga programa sa pagre-record ay karaniwang nagsasangkot ng magnetic tape, digital storage, o iba pang recording media. Option B, providing DC supply, is not the primary purpose of vacuum tubes in a radio transmitter. While vacuum tubes require a power supply, their main role is not to provide a DC supply but rather to generate and amplify radio frequency signals. Ang option B, na nagbibigay ng DC supply, ay hindi ang pangunahing layunin ng mga vacuum tube sa isang radio transmitter. Habang ang mga vacuum tube ay nangangailangan ng power supply, ang kanilang pangunahing tungkulin ay hindi magbigay ng DC supply ngunit sa halip ay bumuo at palakasin ang mga signal ng frequency ng radyo. Option D, providing lighting inside the studio, is also incorrect. Vacuum tubes are not used for lighting purposes in a studio setting. Lighting is typically achieved through specialized lighting equipment such as bulbs or LEDs. Ang option D, na nagbibigay ng ilaw sa loob ng studio, ay hindi rin tama. Ang mga vacuum tube ay hindi ginagamit para sa mga layunin ng pag-iilaw sa isang setting ng studio. Karaniwang nakakamit ang pag-iilaw sa pamamagitan ng mga espesyal na kagamitan sa pag-iilaw tulad ng mga bombilya o LED. Therefore, the correct answer is C. Vacuum tubes in a radio transmitter are used to generate high-power radio waves. Sa makatuwid, ang tamang sagot ay C. Ang mga vacuum tube sa isang radio transmitter ay ginagamit upang makabuo ng mga high-power na radio wave.
I can do all things through Christ who strengthens me. Philippians 4 verse 13.
I hope you enjoyed and learned something new from our topic on physical science. Lead reviewer. If you learned something from this video, please give this video a thumbs up. Don't forget to share this video with your friends. If you have comments, questions, or suggestions, you can leave a message in the comment section below. Thank you very much for watching my videos. Hoping that we meet again in my next video, and God bless you always. It is the Teacher Lumaban YouTube channel.